Another talk for August 9th, 2015. I'll go ahead and link these web pages to the bottom of this video for people who are interested. Exoplanet.eu is a good place to find a lot of this information. Just click on the meetings tab and you'll see a whole bunch of different meetings. And just for fun, I clicked on the top tab, which is currently on there, August 3rd to August 7th, 2015. It was held in Copenhagen, Denmark. I can't pronounce that word, but you'll see it there. The NBIA Summer School on Protoplanetary Disks and Planet Formation, of course. I click on that, and I'm taken to the main page. And if you'll scroll down for the Monday schedule, you'll see that there's Introduction to Planetary Systems and Overview Lecture on Planet Formation. Go ahead and click on the slides portion of that and pull that up. And you'll see a whole bunch of slides and kind of like a little slideshow, because it was probably a presentation speaker. And you'll see it says Overview of Planet Formation, and the gentleman who made this was Phil Armitage of Colorado, University of Colorado. And I think it's great because right off the bat he goes over the initial conditions, which he assumes the initial conditions are a giant disk. Obviously that's the main topic of the talk. And then there's this big bubble that says Planet Formation and question marks underneath it. I find that to be really, really funny, but of course it's a question mark. And overview, it says what sets the size, density, mass, magnetic field strength of disks. Basically, it just asks some simple questions. You know, it throws in the assumptions in there as well of how they think everything works. But yes, I skip over all the math, skip over all that stuff, because what they needed to do was get the principles correct, the very beginning principles, based off of what we've been finding out, and the fact that a lot of the previously held principles were completely, should I say, done away with. The qualitative differences, not quantitative, the qualitative differences were where they made huge mistakes. It says here, if you'll scroll down on the PDF to see, what page would this be? It doesn't have here. Oh yeah, page 22 out of 35. It says many qualitative differences compared to the solar system. They said they have eccentric orbits of giant planets, which is really strange. Hot Jupiters, which are Jupiters that are orbiting really, really close to their host star. Inclined orbits, which have different spin axes. Super-Earths, mini-Neptunes, and close-in Kepler systems. And then it says, there is no fully agreed explanation for the origin of these differences. Now, if you'll notice, they want a fully agreed explanation. They're automatically looking for a consensus without actually trying to explain what's going on. And I think that's a very bad approach to something as incredible as objects orbiting stars and other star systems. You shouldn't worry about consensus. You need to explain what you're talking about first, and then you get the consensus. But more on that later. See here, you have open questions. This is page 28. It says here, what is the origin and nature of turbulence and angular momentum transport in the gas phase? They still don't know what the angular momentum, how the angular momentum is lost. And the answer to that is there is no angular momentum lost. Their protoplanetary disk model is not the way planets form. A planet is an evolved star. The star cools, collapses, and shrinks upon itself, differentiating its interior as it dies, becoming the planet, losing mass to solar wind, coronal mass ejections over many billions of years. And it says here in bullet points, what is the role of low ionization on MHD processes? The role of low ionization MHD processes, well, you'd have to apply MHD processes, which are magnetohydrodynamics. I already talked about that in a previous post. You need to talk about that in terms of the star itself. There are no MHD processes in the vacuum of outer space. The only MHD that exists is inside the star as it evolves, because it's an isolated, not thermodynamically isolated, but it's an isolated, conceptually, thing that evolves on its own terms. The other objects that are orbiting around it are in different stages of their own evolution. They're not related to the sun whatsoever. It's an adopted family. So to place MHD processes to try to explain how all those objects formed at the same time is completely denying the very process or the very understanding of what MHD means. You need to have material there to be electromagnetically forced. And there's no material in vacuum. There's nothing to be forced with MHD processes. So that fails for one. And then you have a bullet point here. It says hydrodynamic instabilities and winds. Those only occur inside of the evolving star. There are no winds in outer space outside of the solar wind and whatever wind the pre-existing object is radiating out from it. So to say hydrodynamic instabilities of an entire solar system, given the vast distances between objects, between Saturn, between Neptune, between Uranus, there are no winds between those objects. They're incredibly distant from each other. Another bullet point is the impact on particle growth, it says here, in planet migration. Now, particle growth, I wanted to make a bigger talk on the whiteboard on that. Particle growth essentially means they want particles to clump together. And they're trying to figure things out by which particles clump together the best based off their size. So millimeter particles, centimeter particles, meter-long particles. But that's not a really good question to be asking because there are no gravitational wells outside a body. So to say particles grow outside a body is deny the fact that gravitation has to already be present. And particle growth happens inside of the star itself when the star is cooling and collapsing and the material clumps together inside the star. It's not outside a body. So particle growth applied to protoplanetary disks is very, very, shall I say, they're headed the wrong direction. That's a dead end. And planet migration, what they're also trying to do is you can kind of sort of telegraph where their minds are. If they think that migration explains the characteristics of the objects and where they're located, they're trying to make it to where everything forms the same way and then they migrate, which is basically destroying the protoplanetary disk model to begin with. So the fact that they even can consider migration means they are trying to throw away the protoplanetary disk model. And lastly, page 33, it says open questions. Essentially, none of the direct evidence from solar system, meaning the chondrules, CAIs, stardust examples, meaning the objects that we can find scattered upon the Earth and meteorites and stuff. Essentially, none of the direct evidence matches simplest expectations from disk models. It says ... what is going on? And you'll have here, I think that's a close-up. I think that might be a microscopic close-up of taenite and chemisite, which is iron and nickel composite inside of some meteorites. But essentially, the reason why none of the disk models can explain that is because the disk models are not valid. If you're going to have material clumped together, it's going to happen inside the star. But then, to make a disk, what happens is you have two objects slamming into each other, releasing interstellar shrapnel. And depending on how much shrapnel there is and the size of the shrapnel will determine what that stardust or chondritic material looks like. It's as simple as that. So when they study dust, which is inside of millimeter, centimeter, and meter long bits, they're studying parts of stars that have been annihilated. They're not the beginnings of planet formation, they're the end. They have it backwards. And then you have well, I guess that's really it. I just wanted you guys to see that the fact that they still have these problems and they haven't been able to solve them. Yet they have this superior technology and they have all these ways of looking at these objects, yet they have yet to make the more reasonable conclusion that their assumptions, their most basic assumptions, are false. And that's what are getting in the way. Such as the sun being the same age as the Earth and all the other outer objects being the same age inside of, this system. But they're not all the same age. Yeah. I guess that's really it. Hopefully people can see this and click on it and learn how to spot a lot of these problems inside of a new theory that I've been developing, because we can't move forward unless we can flush out all this stuff and really, clean house, so to speak. All right, later.